Hi guys, welcome back to the channel. In today's video, I'm going to be showing how to deploy a gaming PC in AWS that we can then access over the web browser. And as the video is showing, it gets decent performance. This is completely remote. We are using EC2 instances with the G series, which essentially means they come with a GPU, an NVIDIA GPU. So, as with most of my videos, I'll be providing the infrastructure as code. So I use Terraform to basically spin up these virtual machines with the GPUs attached. But before I dive into that, I just want to cover some of the reality checks and some things to be aware about. So, firstly, the cost climb could be quick. So please monitor this. Please use it at your own disposal. It can quickly rack up if you don't monitor it. Um, Another thing is latency. So no matter how powerful the instance is under the hood, if your internet is not great, um, then you might feel the, the cons of that. Um, I'll firstly show you how to do the GPU quota, because new AWS accounts might not be allowed to use the G series GPUs, but that can just be requested and you should be fine. Yeah, so the first thing I want to show today is requesting these G instances. Now, the reason why AWS doesn't give them by default is to prevent fraud and new accounts being created that exhaust all the resources. Um, so the first thing we want to do is go to the console and search for service quotas. So clicking on that, and going to dashboard. You can kind of see here on this dashboard the quotas that you're getting near or not getting near. I'm going to go to AWS services, then search for EC2, this one here. And then the type of instances you want to use are the G instances, but they're going to be on demand. So if I was to search for demand, running on demand G and VT instances. As you can see, my account has already got 8, so I don't need to request any more. But to do so, you would click request increase at account level, set the number you want to increase to, and then request. Now, it's important that you don't request 50 off the go because it will likely be denied because you've got no justifiable reason to need that many on a new account. Um, the other thing is just be patient on how long it takes. It really depends on, I guess, AWS's back end to decide whether you're allowed them or not. But I think it should only take about 10 minutes for that to be an account applied level quota increase. Right now, most of the prerequisites are done. We can start with deploying this Terraform. So you will need your AWS credentials in your terminal. The first thing you want to do is copy the terraform.tfrs.example to the Terraform TFRs. So this will provide us with the variables we're going to be using for our deployment. The first thing you want to do as well is then curl to get your public IP. We use this to only allow you to RDP to your remote box that you deploy. You can also change the instance type if you wanted to and the amount of storage you give it. And these variables here essentially within the scripts will install the NVIDIA gaming drivers and accept licenses for you. Alright, once we've filled in the TFRs files with our variables and our public IP address, we can change into code and run a Terraform apply. Now, that's fairly quick. I'll go through what we're deploying now in a second, but if we start deploying that, because this does take about 10 to 15 minutes to deploy, because essentially what this does is it not only deploys this instance with a GPU, but it also runs these scripts to start doing some configuration for us. If I scroll down into here, we can see I set tags on the instance so we can see the steps it's at. And so the first thing it's doing is configuring the audio. We've got things like game volume formatting, the DCV, so that's our web interface to access the game, install in there. This is then to set up the drivers. Then got sorry, this is the NVIDIA drivers. So yeah, what we can do is, whilst that's deploying, is go back to AWS, go to EC2 instances. We can see we've got an instance running now, so it's our cloud gaming instance. Now if I go to the tags, we should see soon some tags populate here of the current status at. So after about 3 minutes, I can start seeing some tags, so where it's currently at in that build stage script. It's good to monitor this because we can see what it's doing and we can track the progress of this. So don't be alarmed if your Terraform says it's completed, but the instance is still deploying and it's not connectable yet. So the first thing we could do actually, whilst we're waiting for that to fully deploy, is firstly get the password for this instance to log into. So there's a command in the output called Terraform output tag raw administrator password. So I can copy that. Now I can see the password here. It's important you don't copy the last percentage. I think that's just the formatting of my terminal where it's got a percent sign there. So some other things it's outputted for us is the DCV browser URL. So this would be the URL we go to authenticate in and be able to play our game from on our browser. It also tells us where we've stored our drivers. We've also got a private key we can use to SSH to the box, and just some other information. So if I now go back to AWS, let's see where we're at. So 5 out of 11. Yeah, so it's installing DCV now. So I'll come back once this is complete, but it can take about up to 10 minutes. Okay, so the instance is nearing completion. So the last thing it's doing is actually installing our benchmarking tool we're going to be using. Now I'm going to go back to the Terraform and copy this URL. I will also use this in Chrome just because it's a little bit better with the copy and pasting across the instances. So I'm going to proceed with this. You're going to get a SSL certificate issued because it's a local certificate used, but you can just proceed with it and it should eventually load. There we go. So the username is administrator. Then going back to the Terraform, I've got the password here by running the above command to output that password. Paste that in there and we should be routed to our desktop environment. Just whilst that's connecting, there is a great bit of documentation here about someone who's streamed a remote environment with nice DCV over quick UDP for 4K monitor at 60 frames per second. So this is essentially what we're doing, and it's a really good bit of documentation. There's the manual approach rather than the infrastructure as code approach, and I'll link that below so you guys can take a look at that as well. Perfect, so we've now got our desktop environment. I'm going to click allow, copy and paste. It essentially means you can copy into and out of this virtual machine. So the first thing I'm going to do now is check whether our instance has actually got a GPU attached to it. And to do that, I'm going to go into here and type in PowerShell, Windows PowerShell, and now we can run a command, NVIDIA SMI, and we can see here that we've got our NVIDIA GPU attached here, and its utilization currently. Another way we can look at that is Task Manager, and if we expand this a little bit, more details, performance, we should see the GPU here. If it's not here, try rebooting the instance. Another thing you might see is this red notification, no license available. So when you're deploying nice DCV on an EC2 instance, it recognizes it and it will give you a license by default. So the next thing I want to do is install a benchmarking tool, and one I'm going to be using is Unigine. And the one I like is this Unigine benchmark, and I think I'm going to go for that one. Free download, and this will install this benchmarking tool, and I'll come back once that's installed. Perfect, so that installed fairly quickly. So when I go to downloads, let's double click that. Next, accept the agreement, next, install. Whilst that installs, I'll just show you guys another trick. So we come to the top right and click on preferences. We can then go to display and we can show the streaming metrics in the toolbar. So what this will do is up here we can see our FPS and our latency now. So when we're playing games, we can also see what the actual browser is giving us back as well. And for those interested, we can come to this website and we can see the actual specs of this instance. So for 4 virtual CPUs, 16 gigabytes memory, um, now an NVIDIA A10G architecture GPU. Um, but yeah, all the specs are here for you if you want them. There is also other G5 instances types that we can use, which are a bit bigger but also a bit more expensive. So just be careful when using these. Okay, so once the benchmarking tool is launched, we can change things like the preset to higher quality, lower quality. So if I go to 1080p extreme and select run, this will now boot us into the game, and we'll be able to see a little benchmarking. So as the benchmark goes, we can see our FPS in the top right, and we can see our FPS that the browser's given us as well. Now this performance isn't too bad considering it's over the internet and on an instance in the cloud, and the quality is pretty decent as well. So thank you all for watching, and just to conclude the video, I'm just going to run a Terraform destroy just to tidy up essentially our configuration, just so we don't accrue costs when we don't need them to. So going back to a Terraform, we can run a Terraform destroy. Now, if you wanted to keep this instance up for longer, you can just stop the instance in the cloud, but I just want to show you guys how to tear it all down to save costs as well. So thank you all for watching. Any questions, please leave them in the description, and I'll see you in the next one.